Welcome to my workshop. Today I'd like to show you my latest woodworking project, a miniature Catapult marble machine. This marble machine is very small. It only measures 200 millimeters in length by 120 in depth by 160 millimeters in height. And what it does is it catapults stainless steel ball bearings from this location up into the catch bucket, and the ball bearings then roll down a series of tracks with some flip-flops back to the beginning position. I was inspired to make this marble machine after watching several videos on YouTube by Denha in Japan. His marble machines are the absolute bomb. Come on in for a closer look and I'll show you how it works. The marble machine is powered by two AA batteries for a total of 3 volts, which drives a Solarbotics GM18 micro metal gear motor. The micro metal gear motor has a 30:1 ratio built into it. You can see it's quite tiny from this clip. And that gear ratio is further reduced by a 16-tooth pinion and a 60-tooth driven gear on the unit, giving us an output of approximately 57 RPMs on the cam. Initially I had a 10 millimeter step on the cam and the balls were not shooting high enough, so I stepped that up to 15 millimeters and found that the balls were shooting way too high. So I eventually settled at about 13 millimeters on the step on the cam, and that seemed to give me good elevation on the balls. The cam follower is spring loaded with a extension spring, and that motion is transferred to the launch mechanism by a 1 millimeter diameter brass rod. At the front of the launch mechanism there is a counterweighted linkage. The counterweighted linkage separates the balls so that only one ball goes onto the launcher at any one point in time. The 400 series stainless steel ball bearings that are used on this Catapult are 9/32 of an inch in diameter, or 7.13 millimeters. I found out the hard way that the 400 series stainless steel is slightly magnetic, and if you pick up the balls with a magnet, the balls will have a tendency to bridge in the entry area to the Catapult, which required me to demagnetize the balls in order to have the Catapult operate successfully. When the first ball drops out of the catch bucket, it gets caught in the first latch, and the second ball gets caught in the second latch. The third ball goes over top of both, falls down, and releases the 2 balls in the latches. 2 of the balls go onto the accumulator, and the third ball falls into the loading table. You will notice that the latches are counterweighted so that they always return to the vertical position. It took me several iterations with the amount of counterweight and the slope of this bottom track in order to prevent the balls from stalling when it hit the latches. In addition to that, I found it necessary to put a groove on the side of the latch in order to guide the ball straight down into the track below. The accumulator is counterweighted with an adjustable screw on the back. When the third ball falls onto the accumulator, the accumulator tips forward and releases the balls, and then they go into the loading table. Okay, now that we've had an overview of the design of the marble machine, let's fire it up and see how it works. Hi guys, that's the end of my video. In conclusion, I just wanted to say that this marble machine was definitely one of the more difficult projects that I've worked on. A number of the elements took several iterations in order to get it to work. It was definitely more difficult than I thought it was going to be. Well, I hope you enjoyed the video. Thank you for watching. If you have any questions, please feel free to post them on YouTube. Take care, and bye for now.